Good afternoon. A warm welcome to our SIBE 2025 event. It's my pleasure to host you besides Urvi, who will be my co-host, and she's just coming over there. So a small introduction about myself. Myself, Soumya and Swami, Vice President with Wells Fargo Solutions. I'm the host for this track, Cyber for AI. Any insights or any two-liners, what does cyber for AI means? Anybody? Anyone? Just a guess, at least. What is the expectation of this track and what do you think? Yes, one second.
First of all, I'm traveling from Kolkata. I'm very happy to be here today in Bengaluru, the tech city. I usually visit Bombay, but I'm very happy to be part. And to be in this track, the reason is that why cyber? Because in this date of data privacy and everything, you are using responsible use of AI. AI is the need of the hour. How you know? So we have to take AI can be a boon or a bane. It's how you use it. And I feel cyber protection for AI is the need of the hour because with data privacy laws coming in, we have to ensure that our data, private or personal or sensitive data is not being misused. So this is my few thoughts I share.
Thank you so much, sir. Glad to have you around. So let me just get a quick intro about what our track is about. So as AI adoption grows, right, so is the risk. So with this great intelligence, how we do, the great vulnerability also takes place, right? So the more the risk, the more the automation, a great vulnerability, we get exposed to it. So basically what you can expect from this track is, it is all about how are we securing the AI systems. And throughout next until 3:30 or 4 o'clock, we have a fantastic combination of our esteemed leaders from all over the industry who are just trying to take insights about how do you secure in an AI world. Having said that, from the misuse of large language models to our adversarial attacks, from poison data sets to governance frameworks, today we'll deep dive how do we protect all this, putting up pipelines, enforce guardrails, and design secure into AI. So we'll explore the full life cycle of AI security, model integrity, data protection, adversarial defenses, access control, privacy, and yes, even spotting invisible threats around you. How they weak are, have. Don't you think it sounds exciting? Isn't it right? So I heartily welcome all of you to our SIBE for AI track, where we'll take through with the industry-led spanners. And here we go. We will start our first session, demo session, Rethinking Access Control for the Agentic AI era. So in the era of this Agentic AI, right, access control can't stay stuck in the past. It needs a serious rethink, right? Please welcome Tushar Agarwal, co-founder and CTO of Reva AI, besides Yash Prakash, identity enthusiastic, on the stage to lead this show. Hearty welcome Tushar and Yash.
Good morning and close to good afternoon, I guess, everyone. Appreciate you taking a bit of a break and joining us in this session, which is the track for Cyber for AI, right? So we will be talking about more about access control, which is a very critical aspect of AI. Perhaps you already know why and how access control plays a pivotal role here. So we will talk a bit about that. Given the previous sessions in the main stage was also around AI adoption and security and risk and challenges, I'm going to skip through or probably breeze through some of the slides that I had put together, and then we will dive right into the demo and see how Reva how a platform should be thought through from a securing AI standpoint, right? So in not too into the distant future, we will have a lot of agents around us. Agents will be everywhere. And we heard from the panelists that there are various use cases that are being put together from experimentation to actually moving these agents to production, right? So we are going to see in enterprise scenarios, there would be a number of different use cases. It could be automating the supply chains, booking your travel, or handling the IT help desk or what have you, right? So we have already seen the adoption of AI uptick already. And again, what we discussed, this has been a significant jump in the adoption, and especially this technological shift has been crazy fast, right? If I put it that way, it is significantly faster than what we had seen with the cloud adoption or the social, SaaS adoption, especially in the enterprise space. This is actually creating a lot of disruption. Right, so enterprises are putting agents or use of AI or ML, and again, this has been going on for close to a decade, yes, but with generative AI coming into picture and general awareness of AI in the market, enterprises are embedding AI in all the business workflows, right? Now we see that an AI first enterprise is emerging. Probably a couple of years back, you saw that every company is a tech company. Now you will probably see that every company is going to be an AI first company, right? So that is how much of a significant disruption or significant adoption we are going to be seeing from AI. Now, what are some of the risks specifically from an access control standpoint? So we see that the agents, the AI workloads are going to have over-permissioned access, right? So why? Because there is no framework, if you will, to assign that granular access. Agents will be more goal-oriented. So unlike our current scenario, right, where there are humans and even perhaps machine identities where you are assigning a scope of work. But how is it going to change in the agentic world? Because agents are more goal-oriented. It is going to create their own paths. It's going to create their own data flows. It's going to create their own ways of invoking different tools, discovering MCP servers, identifying other agents, and then finding a way to achieving the goal. So we will see this being more autonomous, more goal-oriented, which means how do you control access? There is the static permissions that we all used to have. Okay, I'll request access, or I'll probably get an API token, or I'll get a OAuth. So all of those things are not going to work because you will unnecessarily creating a lot of gaps with over permission access. The second thing is with respect to data disclosure, right? Now, in order for agents to become more and more independent and autonomous, you end up providing a lot of data. And that data could be sensitive data, it could be confidential data. So how do you ensure as an enterprise and as security practitioners, how do you ensure that the sensitive data is not passed on? Or if it is being used, how do you ensure that it is protected? The third thing is around the auditing itself. Now, for example, you asked, there are obviously a lot of examples on the internet that you can look up, but when you ask an agent to book a travel for you, right? So the agent perhaps has to do a sequence of steps, understanding what the HR policies are, what hotels or air travel can it book, and so on and so forth, right? So the agent is actually working on behalf of you. So understanding the sequence of events And especially auditing that becomes very critical. And if it is opaque, and if you really don't understand how agents are making those decisions, it becomes an audit nightmare, right? You don't have a way to sort of demonstrate, okay, these are the steps that agents took because of this context or because of this intent, right? So it becomes very important for us to understand the audit, and also use of the agents and the overall workloads that we see increases the attack surface. Santa in her panel address did talk about the expanded attack surface, and she was very candid in admitting that she doesn't know how and what that attack surface is going to look like, because it becomes very, very complex. It can get complex very, very quickly. So how do we, so some anecdotes and some data points to sort of establish this, right? This is based on a couple of surveys that have been conducted by identity vendors. The one at the top is by a research firm called Dimension Research, where it is noted that 80% of the agents took unintended actions, right? 80% of the agents. So the confidence that you can sort of establish in these agents to begin with is low. So you need to be aware of this risk. When it came to the CXOs, when about 28 business leaders were interviewed about the security of AI, 25 people indicated that they do not have the right tools or the right solution in place to secure AI and ML systems. And further to that, again, another data point from the dimensional research, where they identified that 54%, only 55% have visibility into that data. To my previous point that auditing is a challenge, people do not have that visibility. Only 54% claim to have that visibility, and I don't know to what extent they will have. So it just goes to show that there is a long way to go, and access control plays a pivotal role in terms of securing the AI or building trust for that. And as security practitioners, you are looking at, okay, my enterprise, my organization is building AI or starting to invest in AI. What should I do, right? So obviously you will have to work on building and standardizing and leveraging frameworks, right? So providing those standard frameworks become important. Identifying the compliance objectives and compliance requirements and align your adoption to those compliance requirements also become important. And essentially, you will have to bring in or bake in that trust and safety into the AI program. So that's what you are looking at as security practitioners. Now, with that said, access control, I'm not sure how many of you are identity security practitioners. Perhaps just to understand the lay of the land, show of hands, who come from an identity or access control background? Okay, there are a good number of folks, so perhaps you will be able to relate to this more, but as security practitioners, all security practitioners in the room, perhaps you all understand how critical access control is, right? So this is foundational, and in the last 10-15 years, we have seen how identity has become the new perimeter, right? So that is the buzzword that we are hearing for the last 10 years. This is going to become even more foundational with AI. Access control will be much more foundational. And for us, the way we see it is this access control has to be more dynamic. Yes, we have access control in place. We have practitioners who are implementing access control and identity solutions for a while. But what we built access control for was for the systems that we are used to, but not for the AI systems that we are going to build, right? So that's where access control has to evolve and become the foundation of trust. right? Now, every control that you can think of, whether it is the data governance, whether or compliance, or the core driver of adopting zero trust, everything sort of hinges on having a very strong adaptive access control. So how should we see the AI stack evolve, right? So what does protecting the AI stack really mean? So I basically classify this in three areas, right? One is the agentic AI, right, which is the buzz, which is what we see growing. And people are certainly building more and more agentic applications, autonomous workflows, building new layers. So that is one. So we have to protect the agentic AI. The second thing we see is enterprises are building RAG applications, retrieval augmented generation, which is essential, right? This is where you're bringing in a lot of data from disparate sources, and that is where you see the value. So the value is not just using generative AI or ChatGPT, but the value is actually bringing the industry data or the enterprise data that is valuable to you and putting it to action. So if I just create an agent for Salesforce, it will only understand Salesforce. If I build an agent for ServiceNow, it will only understand that. But where you see value is bringing all of the data that you have into a RAG pipeline or a data pipeline, and especially applying your core data. So for example, in case of healthcare, it is the patient data. In case of pharma, it is the clinical trial data. In case of bank, it is the transaction data. So all these are not available in the systems that I mentioned, whether it is Salesforce or ServiceNow. This is in their proprietary databases, and to apply AI, you need to have these RAG data pipelines. So that is the second area that we should be protecting from an AI stack. And third is what enables AI, right? So that's your MCP servers, the tools that you are using. So MCP has taken everybody by storm. So MCP was announced November last year, and you probably have heard all the buzz. You probably are already using or building MCP servers, right? So the model context protocol. Now, so when they released, the funny thing is when they released MCP, there was no authorization protocol or spec that came with it. So it was a wild west. Now, after that, a lot of industry veterans got together and they have released authorization spec on top of MCP. They have now iterated over and they have put some RFPs to essentially leverage OAuth as the foundation and building on top of it for MCP authorization. My point is that there are three fundamental things that you have to think from an AI stack: the agentic AI, the RAG applications, and then the tools or MCP servers that would be that this entire AI workloads are going to be using. Right? So how should we be thinking about it, right? So we understood these three areas that we need to protect. How should we protect it? So this is where okay, there was an animation which is not visible here. Okay, so we are looking at 4 different dimensions or pillars for securing the AI stack, right? We start with the discovery of the AI workloads. Essentially identifying, okay, where your enterprise has AI workloads. I got a wonderful question in understanding, okay, how do you discover these workloads, right? So how do you discover all your AI workloads, whether it is agentic systems or MCP servers? How do you discover that? So, so we are the ideal thing to do is by connecting and building integrations where you are building the AI applications, right? It could be your AWS ecosystem, it could be Azure, it could be Google, so those are hyperscalers, but you are also looking at systems like, you are building agents on Crew AI, you are building agents on LangGraph. So being able to connect to those systems and discovering the the agents or workloads. There are some easy ways to discover these workloads. Some are easy to sort of discover because there is a A2A card, which is a Google standard that has come out. So if you have a A2A card, easy to find. If you have built a MCP server, perhaps easy to discover. But not everything is easy to discover, which is where there will be some amount of manual effort or iterative way of discovering AI workloads. So once you discover, you sort of build the registry, you add metadata. Some metadata can be enriched with the help of AI. Some has to be manually fed, especially by application developers or owners who are building that. So first is your discovery. So now you get a lay of the land. You understand, okay, these are my workloads. Now how do I protect it? So what we also do as part of, or what we also recommend as part of discovery is understanding the risk associated with it, right? So where, again, these foundational elements that I'm talking about is nothing different from how an endpoint or a network segment, network element was discovered and risk was associated. It's just that we are applying to the AI world, right? So we have discovered, we apply guardrails which you have to codify, right? So over a period of time, if you really look at endpoint protection, over a period of 10, 20 years, CrowdStrike or McAfee or what have you, they have built the signatures to identify whether an endpoint is vulnerable or not, whether it is risky or not. You need to do it at a much faster pace by building or codifying guardrails. So that is the discovery part, and assigning guardrails that would help identify the trust score or the risk score of that particular workload. Now, if you can also write policies which can essentially see, okay, if the risk score is high, you are not making it live, or you are not enabling it for production and so on. So that's the first piece. The second piece is the enforce piece, where you're essentially using context to drive enforcement. So what we call as the context-based authorization, right? So especially in case of AI, intent and context becomes very important, right? So you need to ensure that that is understood to drive fine-grained, but more importantly, it also has to be dynamic in nature, right? So that is the context-based enforcement or authorization. So this is where standards have to evolve, right? So there is OAuth as one standard that I mentioned. We will demonstrate as part of the demo how we are using something called as SPIFFE, which is another evolving standard from an machine identity management standpoint, and how do we use it is what we are going to demonstrate. So that's the enforce piece. The third is the governance piece, and it's pretty straightforward. You need to design workflows, design policies so that you can protect these workloads, AI workloads, right? So having that governance in place, the policy management in place is very important. So making it more declarative, making it use open source framework like Cedar. So we are again going to talk about an open source language called Cedar, which is used to define these fine-grained access policies, right? So how do you use open source, but at the same time wrap around with capabilities to be able to drive the governance. So that's the third piece. And finally, the observe piece, where you're essentially understanding the risk, understanding the usage, and responding to the threats in real time, right? Because AI moves fast. You need to be at the speed of AI to detect, okay, whether something is going right, something is going wrong, and be able to adapt the policies based on how AI is behaving. And not just how AI is behaving, just capture all the information. Why an agent took that particular action, on whose behalf it took that action, what was the context with which it took that action. All of that has to be captured. So it becomes critical, right? So this is the observability piece. And as and when applications are built in your enterprise, you need to sort of build for this observability. So those are the four pillars. of the solution, and now you can actually see the solution in action, for which I'm going to pass this to Tushar.
Thanks, Yash. So we are running a bit late. She's already prompting me. Originally, I was
Going to touch upon OPA as well.
So I will touch upon that, and towards the end, we can do a Q&A as well, right? 5 minutes, just need 5 minutes for the demo. So what I'm going to talk about is a solution approach for the 4 pillars Yash spoke about, which is discover, enforce, govern, and observe, right? So let's play the video. So I recorded the video till midnight last night. Hopefully it works. Right. So from on discover, right? So as Yash said, your agents may be deployed wherever you want it to deploy. It may be on a VM. It can be on Kubernetes. It can be on crew.ai. It could be at different sources. It is tough to figure out what's the end-to-end, how do you get into a central place, into a registry, right? So, thanks. So this, I have got some agents which are already discovered. Let's say I want to discover new, right? Just hold on to this, yeah. Let's assume that your agent is deployed on Kubernetes or ECS or what have you. So it's not a standard platform. There's no standard way to discover that from LangGraph or Bedrock or standard deployment engines. Let's say we have access to Git repository. Let's move forward. So you give the URL of your Git, and you should be able to identify. Let's say an agent is calling other agents. It's calling MCP servers. You should be able to discover these agents, identify what is it connecting to, identify. Just hold on to this, please. Identify or recommend certain policies. These are guardrails. These can be your prompt-based policies. It could be, hey, this agent is only allowed to be accessed by this user of this department or from this department, or this agent can access other MCP servers only in these conditions. These prompts are not allowed. These PII data is not allowed, right? So those are the policies. So your solution should be able to recommend those policies, attach it between an agent to another agent. You see this blue circle, that's your policy. Attach those guardrails between your policies. These are the example of policies which are attached, if you see. There is a compliance policy, there is a authorization policy. There could be different kind of policies you attach. Just pause it for a moment. But more importantly, your agent is not really owned by a developer, right? Your agent is owned by a business unit, your application. Today, in today's world, or let's say 1 year back, you had applications, you did not have agents. Now you are augmenting your agent to expose your application. So your agent has to be owned by your application. Your agent has to be governed by the owner of the application or the business unit. So you attach your agent to your existing application so that you claim the ownership of that agent. Move forward. Do that. And this is all under discovery. And you are now ready. So as you discover new agents, your MCP servers, LLMs, you sort of get a registry of agents and MCP servers. This registry is important. And you can have, the registry should follow, just go back please. Registry should follow certain open standard like A2A or Nanda index to expose itself to other developers of the enterprise. So that when they have to write an agent which depends on another MCP server or an agent, they have a registry to go to and refer to. They connect to an existing agent so that their agent is much more impactful, powerful, and much more usable, right? Now, you have discovered the agent. Now you want to, let's say, change the policy of an agent, right? You want to attach new policies. Let's say you want to attach a human in the loop policy. For certain actions, you want a human to approve rather than an agent deciding that, hey, it's now approved, right? And it has to be conditional, it has to be dynamic, it has to be contextual. You attach the policies, just pause for a moment. You attach a policies that gets attached to an agent, and now you are ready to enforce. Now, I'll talk about how can you enforce in an architecture slides toward the end. But so far what we did, we discovered an agent, we attached a policy between communication between an agent and an MCP server, and we allowed an enforcement point to use the policy and decide, right? Go forward, please. Now, this is a demo. Please go back a bit. This is a demo of a underwriter insurance application. Now, what this application is doing is it's an underwriter app, right? So an insurance agent is trying to approve a claim or an insurance, right? They are trying to approve a claim to an insurance, right? Just move forward. So let's say someone applies for a certain limit. We have got the documents. So the underwriter agent has a choice. Let's say they don't want to, just hold on please. They don't want to go through an authorization engine. So in today's world, what would happen? You don't want to go to an authorization engine. An agent decides whether I am approving or allowing or denying this request for an insurance, right? That's what happens, and please move forward. Now what you see, there's a delegation, do a standard review, then an agent is processing the request, looking at the documents, trying to review or approve or deny the request. It approved it, but what happened, right? So if you really view the request, just hold on, play please, hold on. So if you look at this request, even though it was approved, there were certain risks which were identified which the agent ignored, right? Because it's not a human, it's finally a piece of AI, right? Which it may not have the intelligence of a human, it has some intelligence. So that's the downside of not involving a human in the loop in this decision. Now the same request, play forward. The same request, let's say I want to run the same request with the authorization engine turned on, right? It is just showing these are the risks which was ignored when the decision was made. Now in the same request which is on review, now the authorization engine is turned on, I've delegated access to an agent to take a decision. Now what agent is doing, it is trying to identify risk, and if it finds a risky action based on the request and all, there is a human in the loop which is now asked to approve this request and these risks actually before the request goes forward. So the underwriter approved the risky actions and it moved forward. Just hold on. So just to summarize, agents are good. Human in the loop in certain scenarios is important. The importance of human should be augmented with what you are doing with agents in MCP servers. Moving forward. Now this is your kind of guardrails, and there are different kind of guardrails you should be able to write. Just pause. There's an authorization guardrail between an agent and a human, an agent and an MCP server, dynamic conditions, contextual. There's a human in the loop I spoke about. There's a compliance guardrails, PI data which should not be leaked. There could be a rate limits. You don't want your cost, AI cost to increase. There could be a prompt based. You're protecting certain prompts, you're protecting certain response. You should be able to write those guardrails, move forward. And more importantly, how do you observe all this protection and enforcement I just showed about, right? How do you observe that? But before I come to observe, this is your compliance dashboard, this is your governance. Here you should be able to see your trust score, how is that improved over time? What is your decision matrix? How much is being allowed? How much is being protected by your authorization engine? What are your daily violations? And you also want to see what were the decisions which was taken in the whole communication topology, right? What was allowed, what was denied, and more importantly, this is where Yash was talking about SPIFFE, right? You want your agent to have a machine ID, a credentialless ways to authenticate itself, not just authorize. You don't want agents spawning off left, right, and center and claiming, I am whom I say I am, without someone validating, are you really whom you say you are, right? You need SPIFFE to validate that. You need human identities, you need OAuth to validate. Oktas of the world do that. Just pause on this. And this is your architecture. Just to summarize, SPIFFE, OAuth for authentication. You have AI gateway or your firewall. You integrate plugins with your service mesh. You integrate your plugins with your existing AI gateway, API gateways, your bedrocks, your SDKs, right? Different ways to integrate with authorization engine. You expose it as a central console. I was showing you the console there, and it all comes together, right? Back to you, Yash, if you can summarize and wrap it up.
Thanks, Tushar, for the demo. I hope you could have done the live demo, everyone here, but I hope this gave you a glimpse of what an access control solution should look like. So, to summarize, so we just saw this, the architecture play out, different components in there. If you are interested in learning more, the different, the gentleman asked about OPA. So whether it is OPA or Cedar, these are languages that are coming up. OPA is a engine, but Rego is a language with which you can build these policies. So the idea is to move from a very static approach towards access control, which exists today, to a more dynamic, policy-based, declarative approach that we should be moving for the future. So it brings you that dynamic nature or the dynamic need that would be essential going forward, especially with the AI adoption. So as I wrap up, two things. So we have to move from the current static models, that is what we are all used to. We obviously, as some of the identity practitioners, different solutions. We have something called as IGA, which is the Identity Governance and Administration. We have PAM, which is the Privileged Access Management. We have Access Management, each in its own silo working to do its own set of tasks. But that model is going to fall flat, especially in the agentic world. So you need to bring that all together, be able to authenticate agents on the fly, be able to authorize these agents or AI workloads on the fly. So being able to do all of that more dynamically is what you need. And the second thing is, none of the solutions at this point use intent or context, because that becomes very critical as you move forward. That is foundational and fundamental. So moving to a more modern approach to IAM or access control is what we will be looking at. So there is a need for rethinking access for AI native workloads, and treat agents as first-class identities or first-class citizens, assign the right approach, or take the right approach for securing that. So I encourage all of you who are in the decision-making roles, or you are exploring new ways of securing AI, to invest in a dynamic, policy-driven, adaptive access control solutions.
Yeah, my question is, when your system generates the Rego language, the policy as a code, are the systems in place to actually enforce in the cloud environments?
Yeah, those are certainly the enforcement. The question is, how do you enforce? So you can create these policies in different languages that are coming up, Rego or Cedar, but how do you enforce? So this enforcement has to happen, and it can happen at various levels. So for example, you can attach these policies at an API gateway level, or a service mesh level, or an authorization framework itself, right? So the enforcement has to happen in a distributed manner. What we recommend is that manage and bring all the policies in a centralized place so that you have visibility into all the policies, but enforcement has to happen decentrally. So you need to work on installing, without getting too much into the technical detail, you need to install enforcement points, if you will, or configure those so that it can work with any cloud, any application, any microservices, Kubernetes, what have you. So yes, there is a solution for that.
So Reva needs to work with their customers, right?
Correct. Correct. All right. So go ahead.
So I just want to know Thank. So there is IG and PAM. So right now is in our industry it's complicated, like how can I say, joiner, mover, and lever process. So in your tool, it is already managed. Like if someone joining or moving to a different team, like that.
So, see, the IGA systems that exist today will continue to exist. So, I think for at least foreseeable future, these systems are going to be there and handle all the JML processes or role changes or role management. All those things will be there. What is happening though is it is all static in nature, in the sense that you assign a role at the time of joining or as part of your job profile or whatever. So things are static at this point in time. It has to become much more dynamic, because agent is not going to come and say, hey, I am this role, give me that role. At the same time, let's say you want to delegate certain access to an agent, so you don't want to give the entire access. You might have a lot of access, and for just booking a travel, you don't want to give your entire access to that agent. So the scoping of that access also becomes important. So the delegation, the scoping becomes more critical as you move forward, and the static way of, okay, I'm going to assign a role, I moved jobs, I have to get this additional access, those things will be there, because that's what we are going to be transitioning out of in the probably next 3 to 5 years. But those solutions are going to be there to support that.
Okay. Because the main concern was the people are having to multiple groups for the access. So if its solutions come, so we can minimize the group risk. Like we can, according to role, it will can suggest they can move to only this particular group. So have the lower elevation level of elevation access, right? So that's what.
Yeah, absolutely.
Sorry to cut short, actually. I know the team is really very excited, because I know we just kicked off with a fantastic session, right? So thanks to Tushar and Yash for taking this honor to be here. And for the people who are aware of it, they have the stall set up right there. So please, I would encourage, if you have any further questions, please reach out to them. And now it's a trivia time. Just hang on to it.
All right. So we spoke about discovery, and I did call out, A to A. So a question here on what does A to A card represent in the context of AI security? Is it the hardware chip that encrypts AI agent data? Is it a credential that to govern what an agent can do when interacting with other agent? Is it a dashboard widget for monitoring agent activity, or a payment token for AI-driven financial transactions?
The
so
first
what does
person to raise the hand.
Credential to govern what an agent can do interacting with another agent.
All right. So how many think it is 2? Okay, that's awesome. So that's the right.
Unfortunately, it cannot be given to everyone. The first come is the first. Can I have a gentleman, please, on the stage? Yeah, sure.
Thank you.
Thank you.
Thank you so much.
All right. So now you know that you are going to get something. So you better raise your hands and answer. So this is the next question. So
I
one
think,
question.
no, that's it,
You're-
because
okay.
we are running short of time. So I really want to take this opportunity to felicitate both Yash and Tushar. So thanks for being there. Thank you so much, Tushar. Yeah. Thank you so much, Yash and Tushar. I think you know where to catch them around, just for your further questions, okay? So next, moving on, we'll start with the session 2.